Hey, what's going on, everybody? Welcome. So, today we're building something together, and I mean from scratch. Nothing installed, nothing configured, just a blank machine. And by the end of this video, you're going to have a fully working, privacy preserving app deployed on a real blockchain. I know that sounds ambitious for one video, but trust me, the Midnight team has made this surprisingly smooth. If you have been curious about Midnight, if you have been seeing it pop up and thinking, hey, I should probably check that out, well, today is the day. All right, let's jump in. Okay, so what is Midnight? And more importantly, why should you care? Here's the thing. Most blockchains, Ethereum, Solana, even Cardano, they are completely transparent. Every transaction, every balance, everything is public. And look, that's great for auditability. But think about it. Would you put your medical records on a public ledger? Your salary? Your voting choices? Probably not, right? There's the problem that Midnight solves. It gives you this dual state model. On one side, you have public state on the blockchain, visible to everyone, verifiable by anyone. Classic blockchain stuff. But on the other side, you have private state. And this stays on the user machine. It never goes to the blockchain. And the really clever part, the two sides are connected by zero knowledge proof. Basically, your app can say to the blockchain, hey, I did this computation correctly. Here's the proof. And the blockchain can verify that's true without ever seeing what the actual data was. It's like, imagine you need to prove you're over 21 to get into a disco, let's say. With Midnight, you can prove that without showing the bouncer your birthday, your address, or even your name. They just know, yeah, this person qualifies. That's selective disclosure. And that's what we are building today. All right, so what are we actually building? It's called the Counter DApp. And I know, a counter? Really? But hear me out. The counter itself is simple on purpose. What's not simple is everything underneath. There's a compact smart contract that gets compiled into zero knowledge circuit. There's a proof server generating cryptographic proof. And there's a CLI app that wires it all together. The project uses a monorepo, two workspaces, one for the contract, one for the app. And I walk you through all of it. Here's our roadmap. First, we install the tools. Then we create the project. Then we look at the actual smart contract code. And finally, we deploy it and interact with it on a live testnet. 4 steps, about 20 minutes. Let's go. Okay, quick requirements check. You're going to need a few things. Node.js version 22 or higher. If you don't have it yet, I would recommend installing it through NVM. That way you can switch versions easily. Docker desktop. This is a must because the proof server runs inside a Docker container. VS Code. Technically optional, but Midnight has a really nice extension for the compact language. I would say definitely worth it. Google Chrome. You will need it for the Lace wallet, which is how you connect to the Midnight network. And one head ups, right now, this works on Linux and Mac. If you are on Windows, use WSL2. It works great. Once you got all of these requirements, we are ready to go. Let's install the Midnight toolchain. All right, 3 steps here, and they are all quick. Step 1, the compact compiler. Compact is Midnight smart contract language, and the compiler turns your code into zero knowledge circuits. Install it with this one line command. You can see it in the presentation. After it's installed, reload your shell and run compact // version. You should see something like 0.30. If you see that, you are good. Step 2, the proof server. This is the thing that generates your zero knowledge proof. It runs in Docker. You just pull and run it, one command. It will start listening on port 6300. Leave this running in a separate terminal. And step 3, the VS Code extension. Grab the v6 file from the compiled GitHub repo. Go to extension in VS Code and install from file. Gives your syntax highlighting, error detection, makes writing compact way more pleasant. That's it. 3 steps, maybe 5 minutes, and your toolchain is ready. Now, let's actually build something. Midnight has this great scaffolding tool called Create MN App. Think of it like Create React App, but for Midnight the apps. Run npx create mn app my counter template counter, and it generates the whole project for you. Once you see the in and look around, you will see two main areas. First, the contract folder. This is where your compact smart contract lives. You have got the .compact source file, some TypeScript exports, and a test directory. Second, the SRC folder. This is your CLI application, the part that actually talks to the blockchain. API layer, interactive menu, network config, all of it. And notice the structure here. This is a monorepo with two workspaces. The contract workspace produces compiled artifacts, and the CLI workspaces consumes them. That separation is going to be really important when we talk about scaling this up in video 2. Now, let's look at the contract code. This is the fun part. Here it is, the entire smart contract. And yeah, it's 6 lines. That's it. Let me walk you through it. At the top, Pragma language version. This just says, hey, I'm using compact version .22 or higher. Think of it like a compatibility declaration. Next, we import the standard library. That gives us built-in types, including this counter type we are about to use. Now, the interesting stuff. Export ledger round counter. This creates a piece of public state on the blockchain. The keyword ledger is key here. It means this data lives on chain, visible to everyone. It's a counter, and its name is round. And then the circuit function, export circuit increment. In Compact, a circuit is a function that generates a zero knowledge proof. When someone calls this, it runs in their machine, creates a proof that the increment is valid, and sends that proof to the blockchain. The blockchain never runs your code, it just verifies the proof. Inside is just round, increment, and 1 to the counter. 6 lines. And yet, behind the scenes, this compiles into zero-knowledge circuits, generate cryptographic keys, and enable privacy-preserving smart contract execution. That's pretty powerful for 6 lines of code. Let's see what happens when we compile it. So, when you run compact compile, there's actually a lot of things happening behind the scenes. The compiler takes your .compact file and produces 3 types of output. First, TypeScript types and JavaScript code. This is what your application uses to interact with the contract, deploying it, calling functions, reading states. Second, zero-knowledge intermediate representations. These are the actual circuit descriptions that the proof server needs to generate proof. And third, cryptographic keys. These are unique to your contract, and they're needed for both proof generation and verification. And all of these get dumped into a managed directory. And what is this directory? It bridges between your 2 workspaces. The contract side produces it, the application side consumes it. Clean separation. This is the part I really want you to understand. because it's a pattern you will use in every midnight project. On one side, workspace 1, the contract package. It takes compact source code, compiles it, and export everything as a proper npm package. That's its whole job. On the other side, workspace 2, the CLI application. It imports the contract package as a dependency. Thanks to npm workspace, that import results locally, no publishing to npm needed. So the workflow is you change your contract, recompile, and the CLI instantly sees the updates. No manual copying, no build scripts to wire things together. It just works. And the beauty of this pattern is that it can scale. Tomorrow, you could add a React front end as workspace 3, a mobile app as a workspace 4, all importing from the same contract package. One source of truth for your smart contract, consumed by multiple applications. Let me zoom into the contract workspace real quick. The package JSON has three scripts that matter. Compact. This runs the compiler. Build. This runs TypeScript and copies the managed artifact to the disk folder. And test. vtest for testing your circuit logic. When you run them in order, compact, then build, you get a clean npm package that any other workspace can import. The export field maps everything up so import just works. The key dependency here is Midnight Network Compact Runtime. That's the runtime library that compiles code needs. It handles circuit execution, state management, proof integration, all the lower level stuff. Now, the CLI workspace. This is where it all comes together, and the architecture is actually pretty elegant. At the bottom, you have the provider stack. Midnight uses this modular provider pattern where each concern is its own component. We can tell 5 components. Private state storage. This is encrypted. Public data, queried through a GraphQL indexer. Zero knowledge config loads the circuit artifacts. Proof generation talks to the proof server. And the wallet provider handles signing and submission. Then, one layer up, we have wallets. And here's something interesting. On Midnight, you actually have 3 wallets in one. A shielded wallet for private transaction, an unshielded wallet for public 9 token transfer, and a DAS wallet for fees. Then the contract interaction layer, deploy, increment, query. And at the very top, the CLI menu that ties the user experience together. All right, the moment we have been waiting for. Let's run this thing. Run npm run setup. This starts the proof server, compiles your contract, and drops you into the CLI. First things it asks, create a new wallet or restore one. Go with create new wallet. It generates a seed phrase. And please write this down somewhere safe. Now you get your wallet address. And at this point, you need test tokens. The CLI gives you the faucet URL. Open it, paste your address, click submit. Takes a few seconds. Back in the CLI, it's watching your balance. And there it is. Now you have T9s. Thus, registrations happens automatically behind the scenes. Now, the exciting part. Select deploy new counter. And wait for it. The circuit executes locally. A zero knowledge proof gets generated. The wallet handles the fees, sign it, and send it to the network. Takes about 30 seconds to a minute. There's your contract address. Now hit increment. Another proof, another submission. And the counter value goes from 0 to 1. That's it. You just ran a zero knowledge proof on a live blockchain. Think about what just happened. A cryptographic proof was generated on your machine, verified by the network, and the state changed, without anyone knowing anything beyond the transaction was valid. That's midnight. Let me break down what actually happened in those 30 seconds. Stage 1. The increment circuit ran locally on your machine. It read the current state, added 1, and produced a transcript, a record of what changed. Stage 2. The transcript went to the proof server. The proof server crunched the numbers and generated a zero-knowledge snark, a compact, verifiable proof that the state's transition is legit. Stage 3. Your wallet figured out the gas fee and attached it. This is the gas of midnight. Stage 4. Everything gets signed and sent to the network. The transaction contains the public transcript and the proof, but not your private data. And stage 5. The validators verify the proof, which takes almost no time compared to generating it. Execute the state transition and include it into the next block. 6 seconds later, it's finalized. The key takeaway: heavy computation happens on your machine. The proof is tiny, and the blockchain never, ever sees your private data. Before we wrap up, I want to show you the resources that are going to be your best friends going forward. This is the official docs, Docs Midnight Network. This is where everything lives. The API reference, the compact language guide, the SDK documentations, tutorials, node operations, everything we covered today and way more. Seriously, bookmark this. You're going to be coming back here constantly. It's really well organized. Whether you are a brand new to the blockchain or you are an experienced developer, there is a clear path for you. And this is the one I'm personally a big fan of, the Midnight Academy. This is a structured learning path designed for deep technical learning. It starts with zero knowledge fundamentals and takes you all the way through building full DApps. And it's hands-on. You're actually installing tools, writing contracts, deploying things, not just reading theory. What I really like is the knowledge check after each module. It's not just read and move on. It actually makes sure you understand the concepts: commitments, Merkle proof, nullifiers, selective disclosure. All the stuff we couldn't cover today, yes, for sure, you're gonna find everything there. If you want to get serious about Midnight, this is the path. And one more resource I want to put on your radar: the awesome DApp repository. This is on GitHub under Midnight Network. It's a list of DApps, starter templates, developer tools, and examples, all built by the community. If you're looking for inspiration or you want to see how other people are approaching things on Midnight, this is totally gold. I especially want to highlight the starter template section because that's where you will find projects like the one we're going to explore in video 2. Community members building real production quality tools and sharing them openly. That's the kind of ecosystem I love being part of. And that's a wrap on video 1. Look what we did. We went from literally nothing to a deployed DApp on a live blockchain. You've got the toolchain installed. You understood the compact language. You have seen the monorepo pattern, and you run actually zero knowledge proof. In video 2, we are taking this to the next level. I'm going to show you how TurboRepo transforms your build workflow. I will walk you through an incredible story template built by the EDA Labs team. And we are going to work all together to make an upgrade to this story template to be ready for the midnight launch. In the meantime, go play with it. Add a decrement function to the contract, change the increment amount, break things, and figure out why they broke. That's the best way to learn. If you want to connect with other builders, the Discord is amazing. Really helpful community. Thanks for watching and see you in the next video.